which is the economics of transformative AI. What I want to do is, we are a relatively small crowd, so I want to keep this interactive. Feel free to interrupt me at any point during my presentation. That is, if you don't mind being live streamed. And yeah, I'll start by just providing a little bit of context and kind of my framing of how I see the recent advances in the space of particularly generative AI agents. Then I'll talk a little bit about what that implies for economic research itself, because my take is we are assembling around this topic here and how to do economic research on transformative AI. And then in my last part, my last third or so, I want to talk about what are the difficult economic questions that are raised by the rapid emergence of transformative AI. So, for context, the way that I view the situation we're in right now is that we are kind of seeing the fourth AI paradigm since the 2010s emerging. At first, in the 2010s, we had kind of specialized narrow AI systems that were extremely good, but at very narrow tasks, let's say image recognition or something like that. And then in the 2020s, large language models started to emerge, which were really the first general purpose AI systems. So they were general in the sense that they were not dedicated to one specific niche, but you could converse with them about anything. They had a pretty broad world model. They could give you recipes or philosophize about quantum physics with you, or give you personal advice and write emails. And of course, when they first came out, I mean, I know GPT-1 was already in 2018, but was pretty much useless for practical purposes. ChatGPT was released in November 2022. It was, of course, not as good yet as these models are today. So we've seen rapid improvements. But then last fall, another paradigm came out. Traditional language models had these well-known shortcomings. They would hallucinate a lot. They were really bad at analytic and reasoning tasks. And these reasoning models that came out in 2024 were suddenly really good at that, which for us as economists is a game changer, because all of a sudden we can use these models as essentially co-authors that can perform highly analytic tasks for us. And yeah, right now we are in the phase of AI agents, which are emerging everywhere rapidly, although right now they are not quite as good yet at a lot of tasks as we envision them to be in the near future. So this is kind of one of my favorite graphs that I show at all of my presentations from Epoch, showing how fast the amount of compute deployed to train frontier AI has scaled over the past 15 years. And this is a logarithmic scale. So that means the linear slope that you can see in front of you corresponds to exponential growth, and exponential growth at a rate of 4.5x per year. So this is really, really fast. And at the same time, the systems are also becoming much more efficient algorithmically. So here on this slide, we see lots of things from like image recognition to AlphaGo and large language models when we look at the top right. And it's kind of difficult to compare algorithmic efficiency across the board. But within any given subdomain here, we've seen large algorithmic efficiency gains over time. And with LLMs specifically over the past 5-7 years, the estimate has been that it's 2.5x per year. So we can multiply these two numbers. We employ 4.5x more compute every year, and it becomes 2.5x more efficient. It means the effective compute, as we economists would call it, is growing at more than 10x. Now, we also have new scaling laws now that reasoning models have emerged. Of course, for us economists, scaling laws are important because in some ways they are something like a production function, right? They tell us how much intelligence do we get out for a given amount of inputs. Uh, the scaling laws for language models, for all AI models in general, are power laws. And we know power laws are something that we commonly use in economics, but they exhibit decreasing returns to scale. So when we went from, let's say, $10,000 models to $100,000 models, the improvement was just as large as when we go from 100 million to 1 billion dollar models. But the costs get increasingly difficult to cough up. So the traditional scaling laws for plain vanilla LLMs have suffered from the growing cost of compute and the fact that reasoning models give us new scaling laws imply that there are lots of, how should I say, low hanging fruits to scale things. And that's, in my understanding, what's behind the rapid progress that we have seen in the last 6 months. There are more than 30 reasoning models out by now. DeepSeek made a big splash because uh, people realized that we can actually produce reasoning models with fairly low budgets. And whenever you start with a new scaling paradigm, at first you start with low budgets and then you scale that up. And that was essentially a reflection of that. Now, all of this has given rise to stark improvements in analytic benchmarks. The latest models, so O4 Mini was just released like 10 days ago, uh, and is better at, for example, the American Invitational Math Exam, which is the entrance exam to the Math Olympiad, than the top 10 to 20 humans every single year. So I guess it's probably a safe bet. It's better at math than all of us on this call. And of course, in coding, we've also seen rapid improvements. All right, so now we have AI agents entering the game. AI agents are systems that autonomously pursue goals, and they need to do three things. They need to be able to do strategic planning. That's something that models have already been decent for more than a year. They also need to be able to use longer term memory to keep track of things and to employ external tools. And that needs to be all stitched together in a way that it works well. Um, as economists, we know that if you have a long chain of events, and if there's even, let's say, just a 1% failure probability at each step, these things add up. And to obtain high reliability, each step needs to be sufficiently reliable. And that's essentially the main challenge that we are experiencing now, why it is taking some time to build well functioning and reliable AI agents. And yeah, that means all the improvements in LLM reliability, the longer context windows, the faster speed that have been developed over the past, let's say, 2.5 years since LLMs kind of entered public consciousness, they are really paying off now. And of course, the expectation is that they will also have growing use cases in economics and in the economy at large. So I want to kind of conclude this section on AI model context with one slide in which I kind of summarize the way that I view our comparative advantage as humans right now. I would say the leading AI systems from all the labs, they have already very broad general world knowledge. They have world models that are much broader than any human. Uh, but we humans, of course, have specializations, and that means right now we can be deeper in whichever domain we specialize in. Um, AI models also have superhuman performance in processing the information within their context window. So in some sense, I would say we have AGI subject to context window limitations right now. And yeah, another issue is, and I guess that's something we all constantly struggle with, when we open up a new chat, uh, we have to deal with the problem that everything from the previous chat is forgotten, whereas for us humans, our knowledge persists. So, in order to take advantage of our comparative advantage as humans, I think one of the main bottlenecks is to information exchange between us human users and the AI models. And a lot of the innovations that people are working on right now are essentially ways to lessen that bottleneck and ways of dealing with that, either by keeping more in the AI or making the information exchange smoother. So, for example, vibe coding would be, oh, we just let the AI do things and we don't really know very much about what's going on inside. Um, and yeah, we can see that that seems to be a pretty promising avenue of leveraging the benefits of these AI systems and working together with them. All right, now I'll turn a little bit more towards how we can use these systems for economic research. But let me perhaps pause for a moment and let me ask you for comments, questions, reactions.
Yes, thanks a lot. One question that I would have is on how you think that human preferences might change in a world where there's a lot more AI systems. For instance, we do tend to compete for the things that are scarce, and so perhaps increasingly social status, real estate in very competitive cities, but perhaps other sources of meaning could also be something that is an increasing demand. How do you think about this?
Yeah, that's a very interesting and very difficult question. So there are some things that are kind of technologically scarce, right? Like let's say we only have so much energy. We have at a given moment in time, we only have so many chips. We only have so much capacity to produce food and so on. And that's technologically scarce. And economics has traditionally been about these technological scarcities and how we can essentially devise systems to, first of all, relieve the scarcity by producing more, and secondly, also how to allocate them efficiently. In some sense, one of the definitions of economics that it's the science of allocating scarce resources. Now, the some of the scarcities that you mentioned, for example, status, are essentially, um, how should I say, they're not technological scarcities, but they are social constructs. And we understand evolutionarily where that desire to form social hierarchies comes from. It's essentially a mechanism for coordinating larger groups of humans, for coordinating tribes and so on. But then if we take like an objective perspective to it as scientists, we also understand that in some ways they are figments of our imagination, right? So the economic analysis of status goods defines them. There are several competing ones, but I think one of the most useful is a status good is something where that is zero sum, uh, where essentially if you get more utility by having it, I get less utility by not having it. Some goods combine a real usefulness plus a zero-sum status dimension. So that also exists. So yeah, one of the questions is, if something is a pure status good, then classic economic theory would say, well, if it's zero-sum, then there is essentially no social usefulness to it. On the other hand, that assumes things like perfect rationality, perfect information processing, and so on. So I think what we can see in practice is that lots of, let's say, subgroups of human society define their own little status goods. And let's say, you can even see this in academic professions, right? Economists have their status hierarchy. Each subfield of economics has its status hierarchy. You have folks that have their hierarchies according to who can play which computer game better, and so on and so forth. And perhaps one useful way of allocating these, let's call it artificial scarcities, is to create as many as possible of them and make sure that everybody feels they are at the top in some hierarchy. And, maybe things like social media are actually doing that to some extent and are creating new artificial status goods that can give people the utility that they derive from being at the top of some imaginary ladder that is not really rooted in the real allocation of resources, but that seems to be a strong desire. Yeah, what do you think about it?
Good question. I don't know, but I imagine that with the fall in the cost and generally the difficulty of generating more information, there will also be a lot more what we might call advertising, marketing, or propaganda to try to induce others to have a preference over certain status symbols. And whether this actually works, the extent to which it is either centralizing or decentralizing with a lot of clusters on what a social status symbol is, I don't know. But I do expect that what people consider to be socially valuable is going to change as our interactions with the environment, the way we satisfy our preferences, and the information we pay attention to will also change.
Yeah. If you do research on it, one thing I want to encourage you to do is to always disentangle what's like the true technological scarcity and what's the status good aspect that is zero sum, and to think about what's the efficient allocation of each of the two. And I think it's useful in economic analysis to separate the two. Any other comments, reactions, not necessarily on status goods, but on anything we've talked about in the context of AI? All right, I'll proceed then. And I heard one more beep.
One short question is, how, as economics field, how would you foresee productivity being measured by companies once you have AI and humans working together?
Yeah, I think that's a very good and a very important question. If you don't mind, I will address that in the last third of my talk. Okay?
Okay.
All right. So I want to talk a little bit about the use of generative AI in economic research. So in case you haven't seen it, I have a project on that with the Journal of Economic Literature, where I published essentially a first piece on the topic in December 2023, and we entered an agreement that I will provide an update and write about the advances in generative AI every 6 months. So there's now an update already published from June 2024, another one from December 2024, and I'm kind of keeping track of the capabilities. The QR code here on the left side allows you to sign up for an update notification, and no worries, you won't be spammed. This comes out only every 6 months. But I think, obviously, you are all very well aware that there is lots and lots of things that AI can help us with in economic research. For the benefit of organizing it, I have kind of broken it down into 6 categories in this paper. They are listed here, and it goes from the process of coming up with ideas to writing things in the end. And in each of these, I have like a whole range of examples that I'm listing on the paper and on an associated website that's here at the left side of the screen, genai4econ.org. Maybe some of you may find it useful to just look through the examples. You are probably well aware of 2/3 of them, but maybe 1/3 is going to inspire you to use Gen AI in new ways and give you ideas that you haven't been aware of. Two things I wanted to showcase, because I was talking about the benefits of reasoning models before. They can really do very complex math, math that would take me hours and hours in, here's one example, 53 seconds. So this was an example where I log linearized a messy, complicated, not particularly deep, but complicated infinite sum. And even O1 preview was already able to do that perfectly. Another example, Joel, this probably reminds you of your first year. Here I asked O1 to write Python code to solve the Ramsey growth model. Before reasoning models were out, AIs just could not do this. It was impossible because you have to solve for a saddle path stable system, and that involves multiple loops, and that was just beyond them. But yeah, a system like O1 can do it in half a minute, and the code is also beautifully written and formatted, which happens if you have the benefit of being able to think about it before you start writing it, right? And this was the solution. Everything checked out. All right, so I've listed these 6 different categories, but what I want to point out that increasingly we can think of these categories as more like agentic components of the research workflow. And if we are the researcher, let's say the purple rectangle here, then we can use different agents for ideation and background research. Then we can use agents like the green boxes at the bottom that do the brunt of the work, that do our coding, our math, our data analysis. And then we use another agent to do the writing. And increasingly, having kind of an efficiently orchestrated workflow of agents is going to be what's going to produce research. Now, there is also a first economic challenge associated with the emergence of reasoning models, the emergence of AI agents. And first, I'll point to this in a very tangible manner. So when AI models first came out in November 2022 for like end users, ChatGPT at the time was free, right? But it took off much faster than anybody expected. So OpenAI quickly introduced a $20 a month charge for like the regular version of ChatGPT that gave you kind of the amount of use that you need to use it productively. and in particular that gave you access to the better models in spring 2023. That was, of course, GPT-4. And that business model worked pretty well for a year and a half until fall 2024. And then the reasoning models came out, which are much more inference compute intensive. And the labs also started to experiment with like little proto agents, like these deep research agents. And they realized, this is getting expensive. We need to raise our subscription so that the cost of the top subscription at the leading labs is now $200 a month. And that happened only within less than 2 years. And now Sam Altman has proclaimed that he will soon offer a $20,000 a month PhD level scientist. So this shows us, like in a tangible way, that we personally experience, if we want to use the top models, it costs more and more money. And I think what this reflects is that there is a growing movement from human compute and the cost to produce cognitive work being mainly to pay the human, to traditional compute, meaning to AI models as being a growing cost to produce cognitive content. And as we see this kind of movement of where the costs arise from labor to capital, this is soon going to have macroeconomic implications. And that's where I want to turn next. So I expect that there's going to be a really fundamental shift, a paradigm shift in where value in the economy will be created. And the shift is so fundamental that I don't think it makes sense to just focus on how does this evolve, like compared to the previous decade, but we have to go further back in history to see a similar paradigm shift. And what I want to propose, and I do this in a paper on economic policy challenges for the age of AI, we need to go all the way back to before the Industrial Revolution to understand what's happening. Back then, we lived in a Malthusian age. In the Malthusian age, the productive structure of the economy was described by basically two main factors. What you produced, which was mostly food and a little bit of clothing, depended on land and labor as the two main factors. So, and if you go back to medieval Europe, for example, and in many other areas of the world, it's of course very similar. If you owned land, you were among the rulers, you were among the most powerful, because land was the bottleneck factor. Land was the thing that we could only get more if we engaged in zero-sum wars with other landowners. On the other hand, labor was a reproducible factor of production. So since land was completely stagnant, Malthus observed that labor would reproduce up to the point where essentially the marginal worker, or as Malthus said it, the marginal person would have produced just enough to survive. So it means the vast majority of the population in pre-industrial ages lived essentially from a subsistence income. They had just enough to survive. Technology at the time was pretty stagnant, and if there was a little bit of technological progress, the population would expand, and in the end, everybody would again be at subsistence level and would live, frankly, materially speaking, pretty miserable life. And then the industrial age happened, and all of a sudden, technology started to really advance at a pace of like 2% a year. And what was even more important, technology now suddenly relied on capital as opposed to land as one of the main limiting factors. And the great thing about capital is that it's reproducible, and it's reproducible pretty fast, like faster than humans reproduce. You can build factories within months, or I guess nowadays it's years. But what that implied was that labor was now suddenly the bottleneck. So if you wanted to produce more output, you could easily create more factories, but you could not easily create more workers. And if you are the bottleneck, it means your value goes up. And in some sense, you can say the industrial age was the golden age of labor, where labor was scarce, labor was the bottleneck, labor earned high returns. And the returns to labor today are something like roughly 20x what they were at the beginning of the Industrial Revolution. So we as workers, we have benefited handsomely from this technological change. Now, what's going to happen in the age of AI? Well, technology will accelerate because AI is going to help us make technological progress, and very soon will probably engage in technological innovations of its own. Capital is still reproducible. We can build more factories when we need them. We can build more robots when we need them. We can build more compute when we need them. And labor is suddenly also reproducible, because once you have sufficiently good AI, and just to be sure, this is not today's models, but these are the models that would correspond to something like AGI or transformative AI or powerful AI. You can just press a button and you have one more virtual worker. Or if we need physical labor, you can produce one more robot and you will have another physical worker. So everything will suddenly be reproducible. And what that means is growth can suddenly explode. Growth is not held back by these traditional bottlenecks. Labor is no longer a bottleneck. Of course, land is much less relevant in today's economy, although maybe after a significant takeoff, we will find new bottlenecks that will constrain economic growth. And yeah, when will this happen? There's, of course, a lot of uncertainty about it. But what I propose in a lot of my writings is to take scenario planning to this large range of uncertainties. And yeah, I'm listing the three scenarios here. One is business as usual. Frankly, I don't think that's very likely. Another one is kind of a slow AGI scenario, where it's going to take 10 to 20 years to gradually obtain AGI. And then what I think is increasingly being discussed in Silicon Valley is that we may have a fast AGI within 2 years, or maybe 5 years if you have a slightly slower timeline. And honestly, I personally am taking that more and more seriously. So what would happen to output and wages? Well, output would just explode when we no longer have labor as a bottleneck. And that's like the aggressive AGI scenario is the red line, and the intermediate 10 to 20 years is the yellow line. But as soon as AI and robots can do everything, you can see here on the right graph, wages would collapse, because if a robot can do the same work as a worker, then the competitive market wage would decline. Now, one thing I should underline on this slide, I'm talking about the marginal product of labor here, assuming a perfectly competitive market. If we are on this fast AGI timeline, I think there's going to be a whole range of what I want to call frictions, essentially societal holdbacks to the fast rollout of AI that will slow down the process. And I could well imagine that let's say we have AGI in 2027, as for example in this scenario forecast AI 2027 that made the rounds in recent weeks. I could well imagine that the actual rollout through the economy will take longer, and that the impact on wages is going to be significantly slower than what this perfect market scenario here depicts. I heard a ding. Does it mean that there was? Did anybody raise their hand? Nope. Oh yeah, Jade, please.
The wages first went up before going down?
Good question. So what happens in the model is that I assume a smooth path towards full automation. And at first, if you automate, but there are still a bunch of tasks in the economy that cannot be automated, then those remaining tasks become even more valuable. And that's why wages go up. But then at some point, there are so few tasks left and so many human workers who want to perform them that they start to go down, and it starts to go down even before full AGI. Does it make sense?
Yeah, thank you.
Great. So, the prime challenge, and in some sense, that's one of my main areas of research focus right now. The prime challenge is going to be income distribution from an economic perspective. So I think there are reasons to expect that under AGI, income will be much more concentrated. And of course, the economy will always produce what is demanded. If the incomes of workers decline significantly, then we may face a sudden hole in aggregate demand for traditionally produced goods, like for the things that you and I buy on a day-to-day basis now. And that would be inefficient from a macroeconomic perspective because we have all the infrastructure to produce, and if people can no longer afford it, a lot of stuff would be idle. So it would be essentially terrible economic management to let this happen. And we would really have to think very carefully, how can we ensure, I'll go back to this graph here, if we have exploding output, yet rapidly declining wages, how can we ensure that we can maybe take just a small bit from that rapidly rising output and give it to the losers of technological progress so that nobody is made worse off? In other words, to use a more technical term, it is very much possible to achieve a Pareto improvement in an economy where everything is growing really fast. And it would be quite a failure if we don't manage to actually implement that. And then we will also face some much more fundamental questions, like similar to the question that Joel asked before. Do we humans actually need work if they can't earn a living from it? Does work contribute, let's say, an irreplaceable source of meaning or a source of status competition that is irreplaceable? My own hunch is that if work is no longer economically useful, which is of course not right now, right? It probably makes sense for our societies to develop new mechanisms to derive meaning. Because, frankly, I don't know how meaningful it is to do something that a machine can do better, faster, and cheaper than what you or I could do. Now, we'll also have to think, one reaction. Jade, please.
Yeah, thank you. Just thinking about this output increasing, but the wages decreasing, and a concentration of income. I'm wondering, I don't know if you think you might have said this already, but maybe demand for everyday goods goes down as...
That might happen, right?
But isn't there a trade-off between companies needing people to want to buy their products, and then that's trading off against people not having as much of the income and demand decreasing?
Yeah, so let's engage in a thought experiment here. I think in kind of the best case scenario, we would make sure that nobody loses out from this amazing technological transformation. And in that case, we can all see how demand will be no problem, right? Now, let's take the polar opposite. Let's look at a dystopian scenario. And, I'm exaggerating it for the sake of the argument now. But let's say everybody, except for like a handful of super rich, lose all of their income and can't afford to buy anything. What the economy would do is it would have to retool, and it would probably shift its productive structure towards producing what's useful for, at first, that super elite, but then more and more what's useful for the machines. So you would have an economy that switches from animal farms to server farms. And once that switch has taken place, you can see how everything may work very well, how demand may be in balance with supply. It will just be a different sort of supply. It won't be the goods and services that you and I like to consume, but it will be the goods and services that are useful for the AI economy. Does that make sense?
It does make sense, except in my head, I've got the idea that you have this super rich few companies with many AI agents, and because the demand isn't coming from people anymore, the companies still want to redirect the economy towards the AI agents. But if the AI agents work for the companies, then why would the companies try and produce goods for the AI agents that work for them? If that makes sense.
Yeah, so let's take the extreme case, and let's say we end up with a singleton, a single super intelligent agent that would pursue, could be whichever objectives, right? Some of those objectives could be to explore space and build rockets and fly everywhere. Some of those objectives could be to do research, to use energy more efficiently, to produce more energy, and so on. So whichever objective these entities would pursue, the economy would essentially develop around those objectives. And I think we have to, we have to think a little bit differently about that kind of economy. It would no longer be anthropocentric objectives that would drive value creation, but it would be a potentially much broader set of objectives.
Yeah, I wanted. Yeah.
Somebody, can you mute, please? Okay, sorry. Mikoljach? I don't know if I pronounced your name right.
That's all right. Can you hear me? Is my audio correct?
Yeah.
So I thought that if we, you're talking as if the AIs are gonna have some kind of an agency on their own that's like not related to the tasks they were given. Currently, we mostly have AIs that just do the job we assign them, and then they kind of die. And they are not like, they don't buy cars, they don't need like nice clothes and things like that. Why would they pursue those goals? If they are you assuming that the AIs are just not going to be aligned or controlled by us?
It could be either way, right? It could be an AI that explores the universe on behalf of us or on behalf of whichever owner it has. It could be an AI that explores the universe on its own, right? And in both cases, it would build rockets and do space research and so on. So yeah, it could be either way, but I think the way that I want to encourage you to think about it is that after an adjustment, the economy would produce whatever the objective of the agents in charge is going to be. And yeah, as you point out, that could be a misaligned objective, but it could also be an aligned objective. For economics, in some sense, it doesn't matter. And of course, as a human, I hope that it will be an objective aligned with us, right? And I think to connect this with the earlier observation, I also want to say that from my perspective, one of the objectives of human society at large is that we don't experience massive increases, that we don't experience massive impoverishment of people who now derive most of their income from work, which is the vast majority of the population, including, I presume, most of you and myself. All right, so I think we are hitting already our time T. So let me just say, at the macroeconomic level, we're going to need to rethink how to manage aggregate demand. And I think our conversation right now really showcases how important that is. And yeah, I will jump over that. And I just want to end with a call to action to all of you. Let's, in the spirit of scenario planning, there's uncertainty about it, but let's take the fast AGI timelines seriously. And let's say if you knew that AGI will be achieved within 2 to 3 years, what do we need to understand better to make this go well from an economic perspective? What should you or your organization do now to prepare? And also, how would you prepare personally? Thank you.
Yeah, thank you so much, Prof. It was a amazing presentation, and again, like, thank you so much for staying a little past your time. I know you said 10:45, but I know you're way past that.
Yeah,
so thank you.
Sorry for the tech difficulties in the beginning. I thought I should stay for the full 45 minutes from when we actually started, right?
Yeah, thank you so much again. I think we can move on to the next part, which is just like I'm gonna walk through the logistics. But yeah, Prof, you can feel free to stay around, or you can, if folks have questions, is it okay to email you later?
Yeah, feel free to reach out to me. If you're interested in how an economy in which these AI agents take off may look like, you can also find a paper on my website that's called The Rise of Artificial Intelligent Agents. All right, and goodbye to everybody and good luck.
Thank you very much.
Yeah, thank you. Thank you so much, Prof. I'm just gonna quickly run over our slides for the logistics side, but if anyone has questions about the, firstly about the presentation that the professor did, or like if you have a question about the hackathon as such or the sprint as such, just feel free to drop them in the comments and I will pick them up and go ahead and give it to Prof or like answer it over here as well. Let me quickly share my screen so you folks can see. So yeah, again, like, thank you so much for joining in, and I'm gonna quickly walk through the logistics for the next few days. Yeah, so today we had a keynote and we have a virtual mixer as well, which is at 7 p.m. CET, and then we have on Saturday Hack Talks by Yulupai at 1 p.m. UTC, and then by Derek Chang and Joel, who you briefly met, at around like 5 to 6 p.m. CET, and then office hours at 12 and 8 p.m. And then on Sunday again we have office hours, and the submission deadline is the Monday after that. And you can check out all of this on Discord as well. Just go check out events, and you should be able to also say that you're interested, so it pings you when the event starts. And yeah, for this particular hackathon, use the template under submissions for submitting the report. You can join in teams of 1 to 5. And we'll be hacking across the globe. So we have locations in London and Blackpool. So if you're joining us from those locations, feel free to check out the jam sites there. They are in our website. If you go under locations, you can find the Luma links, and feel free to go there and also hack in person. And all our events follow a code of conduct. The apart sprints are held often, so we have one other sprint coming up end of May, which is on mechanistic interpretability with Martian. And so you can find all our previous challenges and projects on Sprints page, and we are a non-profit project. And don't forget to submit your project. The submission button will be visible during the deadline, so it will pop up on Sunday night CET, and you should be able to submit your project. And there's prizes and obviously like a lot of judges involved. So there's some amazing set of judges we have. You can go check them out in the speakers and collaborators section. And we also have 2 area chairs, Matt and Joel, who are also on the call and who you'll see online on Discord. So please reach out for any questions, feedback, and want to give a huge shout out to them as well for making this happen. And we have total of $2,000 in prizes, and this is the breakdown for the prizes. And again, feel free to check out our sprints page. We have like global participants join us for all our sprints, and it's we make sure that it's also completely virtual and you can join us from anywhere. And again, like we are a global AI safety research community. We also, after the hackathon is over, based on the projects that you submit, you have the potential to be included in our studio, which is a 8-week program designed for sprint participants that are excited by their hackathon idea and want to sort of write about it. And then there's a fellowship where like these members are invited to be a fellow and actually like publish papers and present in conferences. And yeah, remember to have fun. And I know like with the sprint, we all tend to overwork, but just make sure that you coordinate with all your team. And, if you're having all-nighters, you eat well and have good energy drinks, and make sure that, you have good communication going on in Discord. If you don't know where to start, we have a project team channel where you can find ideas that you might be interested in. I would say avoid any duplicating efforts, but feel free to check them out. And if they're looking for collaborators or if they're looking for feedback, just feel free to let them know and join their teams. And so we have some wonderful ideas already. Some of them I've posted here, but feel free to again go check out the project/teams channel. And any questions that you might have, feel free to throw them in the chat. And again, thank you so much for joining, and we are ready to kick off the sprint. Awesome. I'm just gonna quickly check if you folks had any questions. So thanks. The virtual mixer is a team matchmaking session that will happen today at 7 p.m. CET. Do check out Discord, it's there on the events. And what we will provide is a way for you to find teammates again, because sometimes like if you haven't found teammates yet, you can still like introduce yourselves and be like, oh, I'm interested in this, and try to find if there's someone else available who is looking for a team. So that's a good place to come and just find teammates. Any other questions, feel free to drop them in the chat. We also have the help desk channel on Discord, so feel free to drop them there as well. And again, thank you so much for joining in today morning. I hope it was fun. And we'll see you during the sessions tomorrow and also like the office hours, and excited for it. So thanks Shahid for your question. So the best way is to go to Discord. You have a project/teams channel and just check the questions there. And then you should be able to check the questions or the ideas that people already have. You should be able to comment and be like, it'll be great if we can form a team, if that makes sense. Otherwise, feel free to reach out to me on Discord. My Discord is usually open. Thank you, everyone. I'm going to shut off the session because I know we went a little over time, but thank you so much for staying. I hope you have a great weekend ahead. Bye.